Welcome to the video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about gain and directivity measurement. So first of all, measurement of antenna gain. So gain is given by the maximum radiation intensity of the test antenna with respect to maximum radiation intensity of reference antenna. So first we need to understand the radiation intensity. It is defined as the power radiated from an antenna per unit solid angle. There are two standard methods for measurement of gain of an antenna: absolute gain method and comparison method. So absolute gain method. So here the two antenna method and three arbitrary antenna method are used. Two antenna method, the input of the transmitting antenna is adjusted to an appropriate level and the corresponding receiver reading level is recorded. So the attenuator dial setting and the power bridge are recorded. Say it is WT and PT1 respectively. Here the absolute gain of the identical antenna measuring setup, where the receiving antenna is used. It is connected to attenuator and receiver detector and indicator, and transmitting antenna is connected to signal source and modulator and through power bridge and detector. So this is the absolute gain method used for measuring the antenna gain. Now the transmitter is disconnected from the antenna and is connected to the receiver through pads. The attenuation dial is adjusted until the receiver reads the same previous levels. The attenuator dial settings and the power bridge readings are noted as WR and PT2. If PT1 is equal to PT2, then no correction is needed. If drifting power is involved, then correction is needed. So here the Friis transmission formula is used where received power is equal to PT, which is transmitting power, and gain of the transmitting antenna and gain of the receiving antenna multiplied by lambda by 4 pi r whole squared. R is the distance between the transmitter and receiver and lambda is the wavelength. Here we can apply the decibels. So G1 in decibels plus G2 in decibels is equal to 20 log of 4 pi r by lambda plus 10 log of P2 by P1. Here since two antennas are identical, then GT it is equal to GR. So if next is the three antenna method. If we do not have the two identical antenna, we can use the three different antenna of gain G1, G2 and G3. So G1 acts as the transmitter and G2 acts as the receiver. We can calculate G1 in decibels plus G2 in decibels using this relation. And similarly G1 acts as the transmitter and G3 acts as the receiver. We can obtain G1 in decibels plus G3 in decibels. And next also we can apply this to G2 and G3. So measurement of gain by direct comparison method. Here the primary antenna is taken. It is either connected to receiving antenna or it is connected to horn antenna. It is given with a fixed attenuator and receiver detector, and it is connected to power level indicating device. And here the secondary antenna is the transmitting antenna. It is connected to variable attenuator, signal source and modulator, and through power bridge it is connected with the detector. Here the variable attenuator is the power control device. At first, standard antenna is connected to the receiver with the help of a switch S. The input of the transmitting antenna is adjusted to convenient level and the corresponding readings in the receiver is recorded. The attenuator dial setting and power bridge readings are also recorded, W1 and P1. Now connect the test antenna whose gain is to be measured in place of standard gain antenna. The attenuator dial is adjusted such that the receiver indicates the same previous readings as that of standard gain antenna. Let the attenuator dial setting W2 and P2 is noted. When P1 is equal to P2, then no correction need to be applied. Then gain of the test antenna with respect to standard antenna is given by P2 by P1. When it is not equal, then by keeping the switch at position 1, PR2 is calculated using pt into g1 g2 lambda divided by 4 pi r the whole squared. So by switching similarly keeping the switch at position 2, PR3 is calculated. So the ratio of PR2 divided by PR3 equal to G2 by G3. So from this G3 is calculated, and we can measure the gain of the antenna under test using this relation. Next, we are going to see the directivity measurement. So directivity is defined as the ratio of radiation intensity in a given direction from the antenna to the radiation intensity average over all directions. So it is also given by the maximum directivity is defined as the ratio of radiation intensity in a maximum direction to the radiation intensity of a isotropic source. So it is the dimensionless quantity. It can be expressed in terms of this relation where it is given by 4 pi by integral f of theta comma phi sin theta d theta d phi. It is the relative radiation intensity as a function of space angles theta and phi. So the directivity can also be computed from radiation pattern measurements, where the first two principal patterns, E-plane and H-plane patterns, can be measured. Then half power beam width of the E-plane and H-plane are determined, where directivity is given by 41,253 divided by H1 H2. These are the half power beam width values. And drawbacks of this method, it is least accurate in measurement. This method gives rough estimates of directivity, and it proves to be suitable when radiation pattern consists of one major lobe with negligible minor lobes. So let's take the assessment. What is antenna gain? What are the two standard methods for measuring the antenna gain? What is Friis transmission formula, and what is the relation between gain and directivity? Thank you for listening this lecture.